Okay, so today we're looking at area between two curves for a second time. And in this example, it did give you the graph or the sketch of a graph, so I'm going to add it to the slide. Okay, so you can see with this graph, please add it to your notes, that it's a little bit different than we've seen from yesterday. So we learned top minus bottom. We have an integral of two things that are subtracted. Okay, and with that being said, that would give us the area between the two curves, right? Now, regardless of wherever these two curves are, they could be above the x-axis, touching the x-axis, below the x-axis, okay, is the subtraction between the two. And for values of x, always look at it, well, what's the top and what's the bottom function? Well, what's interesting here is that if we start to look at what's the top function of our shaded area and our bottom function, okay, it changes once it passes x equals 1. Our top function becomes our line y equals 1, and our bottom function, well, it's actually still the curve. So with that being said, we actually need two different integrals to evaluate, okay? So let's start. So when x is equal to 0 to when x is equal to 1, okay, remember you can write that there. And it's kind of important in later lessons that you do write it. So here we go. The top function was our line y equals x. I'm missing an arrow there. And, oops, I could move that over. And our bottom function was our curve x squared over 4. So that's set. But we have to add another integral with this because we need to go from x equals 1 to x equals 2 to finish finding our shaded area. And now our top function was just 1, and our bottom function was our x squared over 4. Okay, so keep that in mind for something like this, in example 1, and now we could just evaluate it. So I'm going to do that quickly. And let me know if you have any questions. So this is evaluating the first one. This is evaluating the second integral. And then show the substitution. I'm writing these ones and minus signs, but for some reason they're not coming up so fast, so I'm trying to go back and make sure that they're there. So it turns out that after I calculate this, it's 5/6 as our area. You can write the square units. And let's take a look at another one. Okay, so for this one, we're given a parabola. So if you needed to graph it, you could find the vertex by doing x equals negative b over 2a. And so this is the axis of symmetry, and our vertex would be at about 1.5. And this is a polynomial function, so plug in some values, okay? And they're telling us the interval where kind of bounding our area or region. So if they didn't intersect, then you can still find the area. That's why this is given sometimes. Okay, but if they do intersect, sometimes they don't give you this, and then you have to figure out, well, where they intersect, and that's where that homework problem came in, where it asked for points of intersection, to see if you guys knew how to find x when we need x values, and how to find the y's when we need the y values. So important. Okay, so let me try to sketch this out for you. Okay, so I did my best. You can see that I do have some reference points here to just give like a sketch. So they intersect 3 times, which makes it like the last example that I did because the top function is different from the bottom function. Now, I know you can see that they're kind of symmetric areas. So if you do, you can 2 times it, but in this case, we're gonna like separate it. So let's talk about that separation once again. So from x equals -2 to x equals 0, our top function was 2x cubed minus x squared minus 5x, and our bottom function was our parabola, 3x minus x squared. So we have to write dx here and add it with another integral because we have to continue from when x is 0. Sorry about that equal sign. It's a funky equal sign. So from x equals 0 to x equals 2, now our top function is where our parabola continued, okay, past our vertex when x was 1.5. I don't know if you can tell, I tried. When I sketched it to kind of make it look like that. And our bottom function is our 3rd degree polynomial. So I'm trying my best to write that out here. And then we evaluate, okay? What I would do is simplify this because some of the terms can simplify. That will help us when we have to integrate, because then it's just of these 2 terms here. That's a dx, by the way. And just these 2 terms there. Okay. Once again, you can write like the x equals. You don't have to, but I'm starting to include them now because in a couple lessons we're going to start looking at not top minus bottom, but something else when we have to integrate with respect to y. And we need y values. Okay, so for now, x values, do top minus bottom, see what your top function is and your bottom function, and you're good to go. So let me just do the calculations for this and tell you the area. Okay, so show the substitution. And if you don't do top minus bottom, you can end up making a calculation error. Your area might be negative. There's so many issues, so that's why we want to make sure we do know our graphs, we do graph them, we do check what is top minus bottom, etc. Because, well, hey, like I said, it's important. We want to get the right answer. So the area of our shaded region here turns out to be 16, okay, square units. So one more, and then you should really be good to go. Remember to stop and pause the video if I ever go too fast. You're still copying something down. All right, so in this problem is what I was explaining before. You need to solve for the points of intersection. Now, the graph is not given, okay? It just describes, hey, find the area of the regions. So there may be more than one. That doesn't mean that there is just one. Sometimes there is. Enclosed by the lines and the curves. So we have to know how to look at our graphs and find points of intersection. So that would be setting them equal to one another. Especially when you have 2 parabolas, it's probably something on your non-calculator sections. Don't always heavily rely on your calculator. Especially even for like sine, cosines, all those. You can evaluate your points to kind of sketch and plot it out. So you can use your greatest common factor, and 3 can't be 0, but this can be set equal to 0, and we find 2 points, okay, and these are our points of intersection. Now we only need the x values. If you needed the y, you would plug it in to see what your y values are, and it turns out to be 5 for both of them. So just a little side note there. Okay, so we can sketch it out if we needed to. And like I was saying about, at point 5, this is kind of like how you plot your points. And we have a parabola that opens upward, okay, and passes through 4. Oh, that looks like an open circle. It's supposed to be closed. And we have a parabola that opens downward, and at 0, 7, it kind of like passes through. So it's a little bit different. I'm trying to make it go through our points of intersection. So we can see that there's really just one region, even though it says regions, that we need to find the area for, okay? And that is from when x is equal to -1 and x is equal to 1. And our top function is the parabola that opens downward, and our bottom function is the parabola that opens upward. So subtract them accordingly. With respect to x, we can integrate. Okay, what I would do again is simplify, make life simpler. Okay, and again, you can have the x's. So if you want, you can put them in. No big deal. Okay, so now when we integrate this, because it's just really one expression here. Okay, 3 times 1 minus 1 cubed minus 3 times -1 minus a -1 cubed. We end up with 4 square units. So that was our area between our region. Okay, and you should be good to go. Let me know if you have any questions. Good luck.